In this lesson, we are looking at density. Density is the amount of mass or the amount of matter something has over the amount of volume or the space it takes up. Two common units are grams per milliliter or kilograms per meter cubed. Now, right here we have a density triangle. With the density triangle, we're going to plug in our density values. Density is going to be equal to mass divided by volume. So we're going to put our density right here and put our mass over volume. So what you'll see is density is equal to mass divided by volume. We can also manipulate this triangle to now solve for other values. This is where the triangle comes in handy. So we still have our d, m, v. These values do not change. Now, if we're solving for mass, now mass is going to be equal to density times volume. So when you have a straight line and you're solving for it, it's going to mean multiplication. So I'm going to write the equation down here. So mass is equal to density times volume. Now we could also look at it for units. If we use our grams per milliliter, we would have grams per milliliter times milliliters. Our milliliters would cancel out and leave us with grams. Now let's solve for our last value, volume. So we're going to draw our triangle just as we did before. It's still d over mv. We're going to keep this relationship as is. Now we're going to solve for volume. So volume is equal to, and we're going to see now a horizontal line instead of a vertical. Horizontal means division. So we're going to have V is equal to mass divided by density. Let's try it out with our units. So that means we're going to have grams over grams per milliliter. Our grams cancel out, and it's the same thing as saying 1 over 1 milliliter, which means it goes to the top. Okay, let's try a density problem. Let's calculate the density of aluminum, chemical symbol Al, if it has a mass of 8.4 grams and a volume of 3.1 centimeters cubed. Now, I underlined in the problem all the important features we need to know for this. What you might want to do is list them on the side. So we're looking for density. I'm going to put a question mark. You might also want to put an X. It's up to you. Mass is represented by M, so it's going to be 8.4 grams. And volume, represented by V, is going to be 3.4 centimeters cubed. Now let's set up our equation. Density, as we had up here, is mass divided by volume. So we're going to put our mass on top and our volume on the bottom. So we're going to plug in our 8.4 grams here, and we're going to put 3.1 centimeters cubed. Now I'm going to leave the unit as is. It didn't specify that density had to be in a specific unit for this problem. So what we're going to do is 8.4 divided by 3.1 centimeters cubed in our calculator. Our unit, does anything cancel out? No, so it's going to be grams per centimeters cubed. Now I'm using a TI-34-2, so I'm going to do 8.4 divided by 3.1 equals 2.7096. 2.7096. Now let's count the sig figs. All real numbers are significant, so we have 2 and we have 2. So I'm going to count over 1, 2. Does the 0 round up? No, so my answer is going to be 2.0 grams per centimeters cubed. So that is a straightforward density problem. Now let's look at our second one. Diamond, which is an allotrope of carbon, has a density of 3.26 grams per centimeters cubed. What is the mass if the volume is 0.35 centimeters cubed. So the same way that we did our other problem, I'm going to list it down here. Now we're given density as 3.26 grams per centimeters cubed. We're looking for our mass, so I'm going to write a question mark, and we have its volume at 0.351 centimeters cubed. Now look back up to our triangle, and we're going to be solving for our middle triangle as mass equals D times V. So we have mass equals D times V. D was 3.26 grams per centimeters cubed times our volume 0.351 centimeters cubed. Our centimeters cubes cancel out, and so our mass is going to be represented by grams. Now we plug this into our calculator. We're going to do 3.26 times 0.351, and we're going to come out with our answer as 1.1443. Now I took it out further. Now when we're multiplying, we're going to go with the lowest number of sig figs. 3.26, all non-zeros, is going to have 3 sig figs. And this left 0 does not count. So we have 1, 2, and 3 sig figs also here. So we're going to count it as 1, 2, 3. Look behind, 4 does not round up, and our mass for this piece of diamond is going to be 1.14 grams.